How's it going? So today what we're going to be doing is we're going to be just doing some mixed practice, right? So if you're trying to follow along, this is handout 15. So on handout 15, there are 8 questions. We're going to go over 4 of them, and they're just a variety of problems to practice our proofwriting using any technique we want. So I'm not going to tell you what technique to use on most of these, right? And it's just up to you to try and figure it out. And on these 4, I'm going to try and go through like how I'm choosing my technique and stuff like that. So let me go ahead and share my screen here and we'll get started. So the first one, if you're looking at it, it doesn't tell you what to do. It just says, hey, I have these sets, do something with them, right? And with sets, there's really only one way. So with sets, you really have to say, okay, I have to let an element be in the first set, prove it's in the second set. Let an element be in this set, prove it's in the second set. And so for number 1, it's an if and only if proof, okay? If and only if, which means we need both directions, okay? So since we need both directions, I'm going to set it up this way. I'm going to say, here's the forwards direction, give myself some space, and here's the backwards direction, okay? And so the forwards direction means assume the if part and prove the then part. With an if and only if, it's assume the if, prove the only if. That's the same thing. So we're going to assume, okay, A is a subset of C, and B is a subset of C as well. So I have these 3 sets, A, B, and C. I want to assume this if part, and I want to show that only if part. Okay. Well, I'm going to let X, right? How do I show this, right? I want to show that A union B is a subset of C. There's only one way we know how to prove subsets. So I'm going to let X be in A union B. Well, what does this mean? This means so X is in A or X is in B. Okay, all I've done is I wrote down the definition, okay? If X is in A, okay, because there's 2 choices. It could be an A or B. So let's see what happens if it's an A. If X is an A, then X is also in C, since A is a subset of C. If X is in B, well, then X is also in C, since B is a subset of C. Okay, so I assumed what I was supposed to. I wrote the definition down, and then I started using my tools. I knew A was a subset of C and B was a subset of C, so I had to use that somehow. Okay. So no matter what, X is in C, right? No matter what, both cases, X is in C. Well, look what I started with. I started with X in A union B, and I ended with X in C. This means that A union B is a subset of C. Okay. Okay. But it's an if and only if. So I have to do the other direction now. The other direction is like its own separate proof. Okay, so we're going to assume A union B is a subset of C. Okay, and we have to prove A is a subset of C and B is a subset of C. So I have to do 2 things. I have to let X be an A. Okay, well, then X is in A or X is in B. That's fine. That's a true statement. If it's in a set, it's in that set or a different set, right? Because this is the inclusive or here. Okay. So X is in A union B. Still haven't done anything super weird yet, but look, I know A union B is a subset of C. So then X is in C, since A union B is a subset of C. Okay, now I let Y be in B, and it's essentially the same thing. Then Y is in A, or Y is in B. So Y is in A union B. Thus, Y is in C. Okay, and I have my thing, right? So Y is in C since A union B is a subset of C. So no matter what, I got that A was a subset of C and B was a subset of C. So we're good. So thus, A is a subset of C and B is also a subset of C. And we're done. But I had to do both directions because it was if and only if. Okay. Okay. So I'm going to skip number 2, but I am going to tell you that there are cases. Okay. So I want you really to do number 2, but I'm going to tell you the cases. So case 1. Okay. You have to assume that X and Y are greater than 0. Okay, and Y are greater than 0. So that's one case. So they're both non-negative. So I won't say greater than 0. I'll say greater than or equal to 0. Okay. Greater than or equal to 0. Because they can be 0. That's fine. Okay. Case 2 is where you assume X and Y are both less than 0. So they're both negative. You have to see what happens. And then you have to do case 3, where you assume X and Y have different signs. Okay, so those are the 3 cases we're going to need because we need to cover all of our possibilities for a real number X, right? A real number X can either be, they can both be positive, they can both be negative, or they can be one of each. Okay. So that's number 2. Let's skip number 3 because it's exactly like number 1, but let's do number 4. Okay. So 3, it's going to be a similar thing. We're going to use this subset thing and stuff like that. So 3 is like number 1. It's still sets. But 4 says prove if A and B have the same parity. Okay. If A and B have the same parity and C and D have the same parity, then AC plus BD is even. This is another case 1. We have to do another case. So case 1, and we're going to do them all. Well, either A, B, C, and D, they're all odd. So A and B are odd, and C and D are also odd. Okay, so let's try this. Okay, so we assume, and it's going to be kind of tedious to write all of this, but that's okay. So A, B, C, D are odd. That's what we're assuming. Okay. So this means that A equals 2k plus 1, B equals 2j plus 1, C equals 2n plus 1, and D equals 2m plus 1. You'll notice that these all have to be different letters, right? So for some k, j, n, m in the integers. Okay, great. Now that I've done this, I just have to do my addition. What it asked me to do, AC plus BD. So AC plus BD, what is this going to be? This is going to be 2k plus 1 times 2n plus 1 plus 2j plus 1 times 2m plus 1. Okay, and then you have to do the algebra, and there's nothing to really do here. But if you, once you start multiplying it all out and everything like that, you should get this. So you should get 2JL, or I guess well, let's just do it. So this is going to be this is going to be 4kn. Okay, I'm just foiling these out. Plus 2k plus 2n plus 1. Okay, so this is the first thing. Plus, okay, for j m plus 2j plus 2m plus 1. All right, we got this. So what does this give us? This gives us 4kn plus 2k plus 2n plus 2j plus 2m plus 2. I can factor a 2 out of this. Kn plus k plus n plus j plus m plus 1. Okay, well, look, this is even. By definition, since, and then I'm just going to put an arrow, is even, or since that is an integer, the whole thing is even. Okay, so that's the first case. We have two more cases, and they're almost exactly the same. So I'll tell you what the cases are, and I want you to try them and then check out the notes. So they could have all been odd, or they could have all been even. And it's going to be the same thing, except rather than writing the definition of odd, you're going to write the definition of even. And then case 3. Okay, for case 3, well, they have different parity. A and B and C and D have different parity. And you'll notice something that I just say they're different, right? So it doesn't matter whether you make A and B even or C and D even, right? As long as they have different parity. So we use this phrase without loss of generality. So you can just say this without loss of generality. Assume A, B are even. That's what you should do. All right, so just without loss of generality, assume it's even, and then you could say, okay, that means C and D are odd, and then you run through all the algebra again. Okay, so let's try another one. Let's try 5, and then for 6 and 7, so we're going to come back to 5, but let me tell you about 6 and 7. So 6, I'm looking at this and I'm going prove or disprove. Some long complicated thing is even, then n is even, right? What I would do is I would try the contrapositive here and see if I can prove it. And maybe it's not provable, maybe it's false. So that's why I'd try for 6. Okay. 7 is an equality with sets, right? So 7, what you need to do is you need to do the subset this direction and the subset this direction. So this will be very similar to number 1. And then 8 is a prove or disprove, also with sets, right? You still need to do, so I'll say and 8, right? 7 and 8 are both the same. It's practice with sets. It's just like number 1. So when you see a set, there's really only 2 ways to do it, especially with set equality. You have to do, there's only one way to do it, sorry. You have to do both subset directions, right? That's the only way to do it. Okay, let's try 5. It's this new thing called transcendental. So a real number is transcendental if there's no non-zero polynomial f with integer coefficients such that f of x equals 0. Okay, so what that means is I basically cannot solve it, right? If I have some polynomial and I set it equal to 0 and I try to solve it, it doesn't work. That's what we call transcendental. So pi is a transcendental number, e is a transcendental number, okay? So part A says, prove that if x is transcendental, then x is irrational. I just learned this definition transcendental. I don't want to use it, right? So I'm going to try contrapositive. So let's try contrapositive. That's how I do it, right? I look at something, I'm like, ooh, assuming that if seems real tough. then I'll try to use the contrapositive. So this means I'm going to assume x is rational, and I want to show x is not transcendental. So assuming x is rational, well, this means thus x equals, well, I can use a over b, where b is not equal to 0, right? And a and b have to be integers. That's the important thing there. Okay, so I have let f be f of x equals bx minus a. Okay, remember, I'm trying to show it's not transcendental, which means when I plug this number in, what do I want? I want to get out 0, right? That's what the definition said. So this is how I came up with this, because f of a over b, okay, so when I plug in a over b for x, what does this give me? Well, this gives me b times a over b minus a. These b's cancel, and I'm left with a minus a, so I get 0. So thus, x is not transcendental. Okay, that's it for the extra practice. Please try all of these out and then take a look at the annotated notes, and I'll see everyone next time.